Hi there, I'm Rebecca Weaver. We're looking at section 7.3 today, maxima and minima of functions of several variables. This is for our applied calculus class. So we need the definition of relative maxima and minima. The relative maximum of f of xy has a relative maximum when x equal a, y equal b, if f of xy is at most equal to f of ab whenever x is near a and y is near b. Relative minimum of xy is f of xy has a relative minimum when x equal a, y equal b, if f of xy is at least equal to f of ab whenever x is near a and y is near b. The first derivative test for functions of two variables. If f of xy has either a relative maximum or minimum at xy equal ab, and the partial of f with respect to x at ab equals 0, and the partial of f with respect to y at ab equals 0. If one or both of the partial derivatives does not exist, then there is no relative maximum or relative minimum. Now we have a second derivative test for functions of two variables. Suppose that f of xy is a function and ab is a point at which the partial of f with respect to x at ab equals 0 and the partial of y, f with respect to y at ab is 0. And let d at xy equal the second partial of f with respect to x both times and the second partial of f with respect to y both times minus the second partial of f with respect to x then y quantity squared. If d at ab is greater than 0 and the second partial of f with respect to x both times at ab is greater than 0, then f of xy has a relative minimum at ab. If that second derivative at ab is greater than 0 and the second partial of f with respect to x both times at ab is less than 0, then f of x has a relative maximum at ab. Now if that derivative at ab is less than 0, then f of xy has neither a relative maximum or a relative minimum at ab. If that derivative at ab equals 0, no conclusions can be drawn from this test. So let's do an example so we can figure out what all that said. Find all the points xy where f of xy has a possible relative maximum or minimum. Use the second derivative test to determine, if possible, the nature of f of xy at each of these points. If the second derivative test is inconclusive, so state f of xy equals x squared minus 2xy plus 3y squared plus 4x minus 16y plus 22. Oh my goodness. We're going to use the first derivative test. So let's take the partial of f with respect to x. So we do that and we get 2x minus 2y plus 4. We're going to take the partial of f with respect to y. We'll get negative 2x plus 6y minus 16. Now we set both partial derivatives equal to 0 and solve each for y. So let's write them both down and solve for y. We will get, for the first one, y equals x plus 2. For the second one, y equals 1/3 x plus 8/3. Now, we may set the equations equal to each other, solve for x. So set those two equations equal to each other, then solve for x, and we're going to end up with x equals 1. Now, we need to determine the corresponding value of y by replacing x with 1 in whichever equation we want. We're just going to use the easy one, y equals x plus 2. Therefore, y is 3. So now we know that if there's a relative maximum or minimum for the function, it occurs at 1, 3. To determine more about this point, we're going to employ the second derivative test. To do so, first we have to calculate that capital D of xy. So just using that definition, we're going to get that second partial of f with respect to x both times. We'll get that that answer is 2. We'll take the second partial of f with respect to y both times. We'll get that that answer is 6. We'll we'll take the second partial of f with respect to y and then our x. So we're going to get that's negative 2. Therefore, we have that our capital D of xy, plugging that into our definition, is 8. Now, since d of xy is greater than 0 and our second partial of f with respect to x and y is less than 0, we know by the second derivative test that f of xy has a relative maximum at 1, 3. All right, so here we go. Monopolist manufactures and sells 2 competing products. Call them 1 and 2, and they cost $30 and $20 per unit, respectively, to produce. The revenue from marketing X units of product 1 and Y units of product 2 is R of XY equals 98X plus 112Y minus 0.04XY minus 0.1X squared minus 0.2Y squared. Find the values of X and Y that maximize the monopolist's profits. So we know we're going to first use the first derivative test. So we need the partial of R with respect to X. We're going to get that that is 98 minus 0.04Y minus 0.2X. We need the partial of R with respect to Y, and that's 112 minus 0.04X minus 0.4Y. Now we're going to set both partial derivatives equal to 0 and then solve each for Y. So when we do that, we're going to get that y equals negative 5x plus 2450 and y equals 0.1x, negative 0.1x plus 280. Now we're going to have to set these two equations equal to each other, solve for x. So we're going to do that, and we will get that x equals about 443. Now we're going to have to get y, so we plug the 443 into one of those two equations. I happen to choose the negative 0.1x plus 280, and I got y is 236. Doesn't matter which one, you'll still get 236. So now we know that revenue is maximized at the point 443, 236. So let's verify this using the second derivative test. So first we're going to have to calculate that capital D of xy using that definition. So first up is the second partial of r with respect to x both times. Computing that, we get negative 0.2. Then we have to calculate the second partial of r with respect to y both times. We'll get that that's negative 0.4. Then we calculate the second partial of r with respect to x and y. Y first, then x. We'll get that that is negative 0.04. Plugging that into our definition, we get that capital D of xy is 0.0784. Since D of xy is greater than 0, and the second partial of r with respect to xy is less than 0, we know by the second derivative test that r of xy has a relative maximum at 443, 236. If f of xyz has a relative maximum or minimum at xyz equal to abc, then the partial of f with respect to x at abc is 0. The partial of f with respect to y at ABC is 0, and the partial of f with respect to z at ABC is 0. All right. Well, if you have any questions about the homework related to this section, you be sure and email me, and have a wonderful day.